Alright, Military Handbook 1005, 16, also UFC 3 242N. Military Handbook 1005, 16, Package Planning and Small Flow Treatment Systems. General treatment systems handling less than 1 milligram daily are generally considered small flow treatment systems. Military bases often have remote facilities where the groups of facilities serve the small flow treatment system. This section provides general information design with the small flow treatment system as well as the information on specific systems that are not covered with the primary design guidance documentation. Also included in the section is a discussion on proper use of the garbage grinders, grinder pumps, and collection systems for feeding small flow systems and package plants. Type of small flow treatment systems. Primarily, the treatment system used for the small flow application for the package treatment plants and the IMHOF tanks, septic tanks, mound systems, and waterless toilets. Filterization reuse systems are sometimes added with in-off tanks and septic tanks for additional treatment of the influent is necessary with the water environmental filtration MOP 8 addressing in-off tanks and the remaining small treatment systems are described in this section. 612. Unique characteristics of small flow treatment systems. Package plants are units that are generally modularly constructed steel units assembled on site from factory supplied pre-assembled components. The treatment system can be provided with the treatment within a range of about 10,000 gallons per day, up to the approximate 1 milligram per day treatment. The package plant system, the principle of the design do not differ for the large treatment plants, although the choice of equipment usually will. The difference usually stems from the economies of the scale. Certain operations economically feasible only with a large scale. Typical characteristics of the package plant system. Typical package plants layouts are provided in this section. In contrast, IMHOF septic tanks, mound systems, waterless toilets are only applicable to very small flows. Small flow systems must be large safety factor allowances for flow variation, temperature effects, and relatively total wastewater flow for the large treatment system. While small flow systems inherently have less operational flexibility, they are capable of performing effectively, efficiently, and designed criteria of the septic tanks, mound system, waterless toilets, and filterization reuse systems that were given below the following sections. On package plant systems, see also field laboratory studies on on-site household wastewater treatment alternatives, Hollister, etc., AL, 1984, and biological waste treatment theory and application, Grady and Lim, 1985. Packaging plant systems. These systems combine the process for the aeration, settling, and solid treatments in a single multi-compartment tank, and the potential saving result with the design standardization factory production. Type of the treatment process. Refer to Table 8 for the classification according with the biological process employed with the other characteristics. Select the treatment that type according with the biological process. Note that some of the treatments types are required separate primary setting. See Figure 14 for the typical treatment of the plant layout and flow diagram incorporating a secondary treatment activated sludge package unit. 622. Evaluation particular packages. For most treatment types, the competitive packages are available for the different manufacturers. Evaluate proprietary features performance by the cross-section manufacturer without all the operators. Actual installations use package plans certified with the National Sanitation Foundations. Refer to the NCEL CR 70.11 Analyst of Wastewater Treatment Disposal System of Advanced Bases. 623. Performance and criteria certification. Specific requirements based on the elevation describes specified method of operation performance testing and indicate the penalty of the failure to comply with, including conditions required of the removal or replacement. 6.4. Capacity range. These typical populations equivalent for the various biological processes available with the vendors of the awards package units are shown in Table 8. These systems depend on the size may be supplied either by the skilled mounting of assembly or as a field assembly units are then from the package units are supplied. For the manufacturer, the Table 8 also includes the information about the process types as well as the description units, disposal recommendations, aeration methods, and applications. Alright, this is a characteristic of package biological treatment units, Table 8. Alright, activate sludge package installation. Let's move into 75%. Mechanical bar screening or commutators pumping station not shown and going into the air filter aeration zone. Return sludge and super aeration zone supernaut. So the final setting, advanced treatment unit required. Chlorine contact tank affluent with the receiving waters and polishing pond. From the supernaut to the sludge holding to the solid disposal, also excessive sludge, activated sludge, extended all aeration, activated sludge step aeration, shows the mechanical bar screen communications pumping station that shown aeration zone into the supernaut, excess sludge final setting, advanced treatment unit if required, chlorine contact, partial flume, affluent, receiving waters, polish bond, and from aerobatic digester, mechanical and gravity dewatering, solid disposal. Alright, your communicator's mechanical bar screening wet pump station to the aeration zone, also from the supernaut to the return sludge final setting, aerobatic digester, excess sludge, mechanical gravity dewatering into the solid disposal, and from the final setting you have the advanced treatment unit if required, and the partial flume, chlorine contact tank affluent. Let's see, typical layout of figure 14 continued. Mechanical bar screen communicators, wet well on-site pumping station, following to the sludge dry bed, some and under drain, sludge drain bed, sludge drain bed, earth embankment, in number one, and number two, advanced treatment control unit number two, advanced treatment number one. Blower room storage, chlorine, lab office laboratory, chlorine contact tank, flume, and also receiving waters, outfall. Alright, your packets. This is a figure 14 continued. Alright, you have a plant air from the top. 12 o'clock, tank influent, roof return sludge airlift, final settling tank, sludge hopper, influent distribution through typical berm, air diffuser, mixed liquor, final settling influent, well, sludge hopper, mixing aeration zone, foam control pump with the inlet screen spray system, settling tank affluent, adjustable V-note inlet wary, plant air supply head drains, two sludge disposable aerobatic digester zone, valid air feeders, valves are not shown, final setting affluent through, and waste sludge airlift, final setting tank sludge hopper. Alright, 6.3 septic tank system. Septic tanks with appropriate effluent disposal system are acceptable for the treatment system, isolated buildings, single unit residential buildings. Permitted regulatory authority with alternative treatment, practical with the sale of the drainage characteristics, well documented with a particular site, and septic tank treatment may be permanently feasible. Because the septic tank treatment system is a biological process, because it usually discharges directly above the shallow groundwater, it's particularly important that the toxic hazardous chemicals are not discharged into it. Discharge industrial wastewater into septic tanks violates the underground injection provision of the Safe Drinking Water Act, or SDWA. In addition, the grease and non-biodegradable products should be discharged in these systems, since the products can be clogged since they have components. For this reason, use of the garbage grinder for the domestic light commercial facilities served within the septic tank system should be discouraged. For the other use in food and other kitchen waste, there should be the disposal entire through the garbage collection system. Designers are cautioned to evaluate the source of waste carefully between the designing septic tank system and to devise the upstream sewer, user appropriate discharge, and source collection, source control to prevent improper release of septic tank. 631 size. Septic tanks perform settling the digestion functions of actively with a treating of the from 1 to 300 populations equivalent waste. The population equivalent is considered to be approximately 100 to 120 gallons per capita per day. Domestic strength water. Generally, the septic tanks should be used only with 1 to 25 population equivalent, except for the septic tanks are most economically solution for the larger populations with above ground. The minimum size will be at least 500 gallon capacity. In the designing tanks, the length of the width of the ratio should be between 2.2 to 1 to 3 to 1, and the liquid depth should be between 4 to 6 feet. Refer to Figure 11 for the military standard drawing division, standard drawings number 2620-01, 2620-02 for the details of construction. Alright, this shows the plan from domestic wastewater source into the access manholes and to leach welling. Also shows the longitudinal section of the starting at the top, inspection openings, inlet air optional outlet, sludge clear space of 12 inches, longitudinal section, sludge scum clear space, scum liquid level vent inlet, and fire fixed compartment approximately 2/3 length, and a sanitary tree. 632 detonation time. Detention time depends largely on the method of the fluent disposal. The fluent is disposed of the subsurface absorption field for the leaching pace for the 24-hour detention based on the average flow that is required with the septic tank should be sized to provide required detention below the operational liquid level for the design daily flow plus an additional 25% of the solid storage. The secondary treatment such as the subsource for the filter oxidation and provided that the period can be reduced to 18 hours. Open sand filter treatment can further reduce the detention time to 10 to 12 hours. 633. Effluent disposal. Absorption field and leaching well disposal should normally be limited to small facilities less than 50 populations equivalent. If the total population is over 50, there are more entirely separated field of the well should be acceptable for a 10 to more population equivalent discharge. The effluent will be those dosing tanks with periodically discharging effluent quantities nearly 80% of the absorption system capacity. Subsurface absorption. Subsurface absorption can be used in conjunction with the septic tank treatment with the soil conditions permit. The percolation test should be performed as required by the U.S. Public Health Safety Service. The groundwater table, the highest known anticipated level should not reach higher than 2 feet below the inverted lowest distribution line. Adoption fields normally consist of the open joint and perforated distribution pipeline laid in trenches to 1 to 5 feet deep to 1 to 3 feet wide. The bottom of the trench are filled with a minimum of 6 inches of or 3/4 and 2.5 inch rock or gravel. The perforated distribution is laid on top of the rock and open joints begin between the pipe lengths are covered to prevent clogging. More rock is covered carefully over the pipe network and then semi-permeable membrane is used over the rock layer to prevent the finer grain backfill with the clogging with the drainage zone. Distributed pipe may be spaced close to 2 feet, and if the rock beneath the depth of subsoil porous distance between the bedrock greater than 4 feet. General distribution pipelines are 3 to 6 feet apart laterally and no longer than 100 feet, and consult the Environmental Protection Agency 625-180-012 Process Design Manual for open site wastewater treatment disposal system. For the complete details, leach field special design information, minimum depth tanks, which will be 18 inches with a 12 inch of the backfill. Invert slopes will be 3/10% will be dosing and are used to be in 5/10% will not be used. Soil absorption system will be 100 foot from the water supply wells, 50 feet from the stream, 10 feet from any dwelling property line. Soil testing with the required prerequisite further in subsurface disposal waste. EPA 625-180-012. The Chapter 3 specifies the test methods, including the standard falling head, pre-circulating test procedure used for the estimated local percolation rates. Local state regulations should also be consulted because they often provide meaningful guidance for the soil type of the specific geographical areas. Leaching wells. Leaching wells can be with a septic tank effluent with a disposal of subsoil in the pores. Although the absorption beds are generally preferred, but the state characteristic of the cost consideration may encourage the use of the leaching well with the wells constructed with the masonry block of the stone lateral openings, gravel outside of the preventing sand from entering the well. If there are more than one well, it's required space wells at intervals will be at least twice the diameter as well as the distance between the well hole sides. The percolation area is the area with the side of the bottom of the whole leaching well. The bottom of the leaching well should be 4 feet above the seasonal high water and see Figure 1718. Environmental Protection Agency 625-180-012C. 6333. Subsurface sand filters. Septic tanks effluent can also be applied with the subsurface filters. Subsurface exploration are also ways necessary. Clogging installation costs at a significant disadvantage. When recirculatory filters are disposed of, the rate that may be between 3 to 5 gallons per day per square foot. Consult the EPA 625-180-12 for the intermittent sand filterization upgrade wastewater stabilization pond effluents. Harris ETAL 1977 intermediate sand filter design performance on an update Rodane ETAL 1982 for the appropriate and procedure for those site elevation and design parameters. Alright, this shows your distribution box with a 3 to 6 foot spacing, generally minimum trench sidewalls covering 6 to 12 inches unless climate is severely cold. Perforated distribution pipe, and also bed bottom of 18 to 24 inches less than the deep of the cold climate. 3 to 6 feet, 3 to 6 feet, 6.5, 6 to 12 inches, 3 1/4 inch, 2.5 inch diameter rock, 2 to 4 foot minimum water table crevice, bedrock barrier material above. Distribution pipe kept level to ensure the complete even water distribution. All right, your percolation test. In absence of the groundwater, the subsoil information subsoil for the exploration necessary, but the investigation may be carried out with a shovel, the hole digger, or solid auger with the extension handle with the swim cave. For the examination of the road cuts, foundation excavation will give the useful information subsoil for the investigation appear if it's suitable. The percolation test should be made with the typical point for the disposal field to be loaded. The percolation test determine the acceptability of the site and surface base for the design for liquid absorption. Consult the Environmental Protection Agency 625-180-012 for the percolation procedures. 6.4 Mound system. Many installations are sited with low-lying plants, reclaimed swamps with poorly drained areas, source saturated soil conditions, highly clay content with a high water table to show the depth of the bedrock. Slow percolation makes ordinary solid disposal techniques unfeasible. See on-site treatment, Boyle and Otis in 1982. In these situations, the septic tank mound system may be then feasible. Alright, this is your figure 17 seepage pit cross section. You have a 4-inch section pipe with a reinforced concrete cover extending the solid earth. Effluent septic tank and solid outside pit should have the weight of the percolation rate less than 30 minimum inches before all horizontally intercepted. Water table, the 4-inch saturated soil of impervious layer of bedrock. Free effluent additional to pits as required. Brick block ring precast chamber with opening joints or 6 inches to 12 inches, 3/4 inch to 2.5 inch clean rock. The depth of the water table of the zone is interface with the flow. Critical should be porous from readily acceptable wastewater flow. Alright, figure 18 shows the leaching of the field cross section. Alright. Ground surface. Mound allows shrinkage. Backfill maximum 18 inches, also 12 inches, 6-inch minimum from the approved barrier material. Open joint perforated distribution pipe 4 inches. Rock other filter material. Undistributed native soil. Water table crevices. Bed rock 2 foot minimum, 1 by 3 foot minimum. 6.4 description. A typical mound system is shown with the figure 15. The simplified may be replaced with the pump of the mound, but is located with the downslope of the mound itself, which is with the fill material absorption area distribution system. A cap of the covering over the topsoil fluid is disposed of the absorption area through the distribution pipe. The fill material provided with the major zone for the purification before cleans effluently based on passing into the buried topsoil with the original soil line. With the caps of the oil cap is of fill and deep enough to protect the piping. They should be sloped and contain the sufficient silt clay should be encouraged runoff of the rainfall. Topsoil above the seal of the grass to prevent erosion and encourage some of the evaporations, and transpiration. Impervious soils are also shallow bedrock with a mound which should be kept deep enough to provide with the absorption pollution before they can infiltrate the bedrock and enter the groundwater. Site consideration. Table 9 summarizes the soil site with a factor of the restricted mound system, and usually Table 9 percolation tests are usually run from 20 to 24 inches from the natural surface. It's shown slowly permeable soil with a percolation rate is less than 60 minutes per inch, and the soil is permeable so that the slope of the site may cautiously increase to keep the effluent within the upper soil horizon. The percolation rate is greater than 128 minutes an inch, and the soil is impermeable to the disallow use of standard mound system. Soil characteristics with a water table to the mound with large fragments dramatically influencing the mound design. Figure 19 illustrates the mound system with using two trenches, while figure 20 shows the bed absorption system. The further information on the design criteria, installation, Environmental Protection Agency 625-180-12. Depth of pervious rock. A minimum of 24 inches unsaturated natural soil is required beneath the mound. This is natural soil provided with the additional purification capacity, serves as a buffer protecting the groundwater from contamination, and it also reduces the amount of fill water needed for the mound, serving as the part of the unsaturated oil needed for the purification. Alright, this is your trenches mound system. Alright, you have a topsoil, also a marshy hay distribution layer, percentage of the slope absorption area course aggregated, and pipe plowed layer with a pipe from pipe, diversion surface source. Also, the cross-sectional shows the marshal hay, the distribution lateral, fill, 6-inch topsoil, percentage slope trench with 1.5 to 2 inches corrugates at a grade, pipe to pipe, plowed layer, D or E fills for fill depth of 1 foot minimum water table to 2 foot beneath the below soil surfaces. F stands for the trench of the bed depth, minimum 9 inches, 6 inches below the pipe frost projection cap runoff promoter and cap apex, minimum 1.5 foot. Alright, A is the bed trench width, B is the bed trench length, C is the spacing between the trenches, K is the end slope of the length, I is the down slope, J is the upslope, and L is the length. Table N shows the solid site factor for the restricting mounds. Restriction factors: low permissible soil, pervious rock, bedrock, permissible soils with higher water table. Alright, mound system and beds. Alright, you have your topsoil diversion source, surface water, marshal hay, distribution layer, fill, plowed layer, pipe from pipe, percentage slope, absorption area, course areas, marshal fill, hay, fill, topsoil, percentage of the slope, bed of the 1/2 inch to 2 inch course, aggregated pipe from pipe, plowed layer, distribution layer H. Once again, the letters are the same. Distribution in the bed of the 1/12 of the course aggregated. This is your detailed plan for the mounting using bed absorption area. Bed of the trench width, bed of the trench length, end of slope. I is the downslope, J is the upslope, L is the length. 644. Depth of the high water table of the mound system with absorption of the raised above the natural soil will keep the bottom of the trench at least 2 feet above the groundwater, as well as the conceive of the purest rock, relatively impermeable soil. High water tables can be determined directly absorption of the soil mounting, the occurrence of the gray and red soil mounting. Phenomena can be used to indicate the periodic saturation with the water. However, the lack of the mounting does not always mean the seasonal perch water does not occur. Locating of the mounting with a meaningful but directed observation preferable is there any of doubt. Depth of the impermeable soil layer with the rock strata. The depth of the impermeable soil rock strata can vary over a range. See Figure 1920. The optimum distance will vary with a given state, given site. They provide the sufficient area for the effluent to move away from the mound. Otherwise, the effluent will build up in the mound and cause seepage out of the toe of the mound. Climatic features: soil permeable slope system and configuration affected by the distance of the slope. Permeable soils require more than an area to move the effluent from the pound to then the permeable soil. Frost penetration reduce effective area for lateral movement in the warm climate. The depth and the requirements also greater than the colder climates. Level sites require a shallower depth than doing so. Sites of the more available to fluent dispersal since effluent can be moved several directions, less depth is required for long, narrow mounds. It's required for the separate square system. To cover the square system concentrates the liquid into a smaller area. The depth of 646. Depth of 50% volume of the rock fragments. Rock fragments do not assist with the purification and disposal of the fluents, but they also cause the fluent to be concentrated between the fragments. They may lead the saturated flow of the spore of purification. This contains 50% of the rock fragments. Volume is upper 4 inches of the soil. Then there is only a half of the soil available for the purification and disposal of the effluent. The depth of greater than 24 inches should be used if the soil beneath the mound contains more than 50% of the by the volume of rock fragments. This is especially true for the permeable soil of the crevice bedrock and areas where the high water table intersects the potable water supply. Slopes. Site selection very important. The crested earth site with the most desirable to be covered the mound, but the sites for the fluent can move laterally down both slopes. The level site all the way allows the lateral flow within all directions may be present. The problem is because of the water table that may arrive with the higher beneath the mound slowly permeable soils. The most common site is the sloping site there where all the liquids move in one direction away from the mound. However, the proper design can overcome the limitation, especially the less permeable soils. Place the mound upslope and not at the base of the slope on the site where there is a black slope of the saturated mound, such that the liquid is not converted and alone in one area of the downslope. Upslope runoff should be diverted from the mound. Mounds require more stringent slope specification with the conventional system because of their reliance on lateral movement. The fluent through upper soil horizons, lateral movement becomes the more important support. Soil permeability becomes lost, thus more slowly permeable soil. The maximum allowable slopes are less the more permeable soil at 3 to 29 minimum inches. Slopes up to 12% should function without surface seepage because of the lateral movement. It is not so great for tighter soils, 30 to 120 minimum inches. The slope should be not exceed 6%. The slope site and the downslope the distance of the must be length of the upslope distance. J shortened by the table 10 may be used for the calculation. Table 10 shows the correction factor for the downsloping sites. Slope percentage of the downslope correction factor and downslope J correction factor. Alright, site setting, consideration. Construction of the mound system with a well-conventional system with a recommended the floodplain is drain weighted with the direction, generally site with a large tree with the numerous small trees with the largest boulders are used site with the mound system because of the difficulty with preparing the surface with reducing infiltration area beneath the mound of rock fragment, the tree roots, the sump, and boulders occupied space with the reducing of the mound of the soil, the proper purification. If there's no other site available, then it is recommended to cut the trees off of the ground level, leaving the stumps in largely mounted area with necessary. If too many stumps are involved with sufficient soil to be available to accept the fluent, the separating distance should be considered between the toe and the fill. Respective features such as the building well slope with the stream one, the mound fill located over the mounting slope of the building, other features of the soil with the slow percolation rates, the slowly permeable subsoil layers, separating distance should be increased. 649 basal area calculation. The natural soil with the fill area with the interference with the basal area with the fluent with the exception from the overlying mound with the fill through the area is not into the subsoil beneath the four level site with the basal area equal to the mound area for the sloping side of the basal area downslope from the bed and the trenches used in basal loading rating calculation. If it includes for the area enclosed for the B plus A B B's opponent is AC plus IG A plus C plus I plus J for the trend system, figure 15. B, enclosed B, A plus I plus J for the bed system, figure 16. Percolation rate for the natural soil will determine how much area is required for the percolation rates applied with the bound system for the design. Basal loading rates are provided in Table 11. Table 11 shows the percolation rates corresponding to the design loading rates. 6.5. Waterless toilets. Humus composting toilets for the U.S. Forest Service. Several manufacturers have developed several types of the humus toilet for the composition of the option for the human waste disposal for the backcountry. Fake walk in 1975. Utilization of earthborne microorganism stabilization, detoxification, residual sludges for treatment of wastewater. Hierenstein Mitchell for the 1978 humus toilet are watertight depending on the microbiological decomposition, their reduction in volume, their destruction of the pathogens, pathogen cleavage from Maltrum is a forerunner at the bottom of the composting toilet. The Slivis Montrum essentially involves only a toilet seat, large slope container with the floor tilted at 33 degrees to allow the excreta to aerate and gradually move to the base of the chute toward the excessive hatch. Excess moisture evaporates through 6 inches of the roof vent. The system depends on using deposting peat, moss, or soil into the chute periodically. Kitchen waste and toilet paper, shredded paper, or other biodegradable waste should be also added regularly. After about 3 years, once each year, but thereafter the small amount of humus like of the composites may be removed from the access port with usable fertilizer. Humus toilets are simple, very efficient, easily to install. However, they are moderately expensive and are space intensive. Also require slope and must install on the second floor. They should be seriously considered for the mountainous terrain or where buildings are built on slopes. Smaller box-like units will have the design installed with the Scandinavian England, but they require electrical heater. New options: the Sewerless Society Leach of 1976. Chemical toilets. Chemical toilets are used to manufacture fiberglass, expensive and installed with the maintained chemicals used have the high pH and have to be known to cause manner-borne fragrances are usually added with the mask odors because no biological degradation occurs between the cleaning and the after cleaning pump trucks usually transport the treated with the waters and sewage treatment plant chemical units that are less desirable than humus units because they require not only greater energy costs but also constant maintenance and hauling up onto a treated plant. Another chemical treatment method is used with the mineral oil as to transfer land liquid. The units are common with the cargo vessels, national parks, rest areas, and gas stations. They do have the advantage of the chemical toilets. Waste are put within the central holding tank undergo with a considerable degradation ground during the storage and are more aesthetically acceptable. However, their maintenance requires highly trained peer personnel. Ozonation units that coupled with the aerobatic treatment, ozone saturation has been produced with several firms. However, such units installed with California have proven to be inexpensive. 653 aerated pit lanterns on the trains. Military units small size designed with the field's relatively remote outposts might use the aerated pit latrines. The latrines are improved with the version of the preview. The pit may be excavated using a backhoe or hand labor. Usually, the pit walls are supported by 2x4 lumber and lagging. The providing structure is best designed for allowing easy transport to the new location. It may be uncoupled from the pit and the walls to support the carriage to another location where the pit is filled with wastewater within 2 feet of the ground surface. Once the structure has been removed, the remaining pit is buried in the topsoil and seed grass. Some of the modern designs use passive solar panels to produce the rising current with the warm air, which passes out of the screen vent of the pipe of the screen opening to provide the base of the pipe for the structure to allow the cool air to move laterally across the top of the pit up, then out of the vent. Latrines are being operated with the composting toilets and leaves and wood chips and pine straw. Pine straw are add to extra if well designed, responsibly maintain air pits.